Good evening, this is Mr. Win bringing you Unit 4 Lesson 3a, and in this lesson we're going to get to the definition of a parabola. So a parabola here with directrix L and focus point F has a focus point F up here, and your directrix is this line down here. And all that tells you is that the points from the focus point F to P1 here is going to be the same distance as P1 to Q1 here. And similarly here, from F to P2 is going to be the same as P2 to Q2. And all that tells you is that they share the same distance. And in fact, this focus point here, all it tells you is that the distance from the focus point to any point on the parabola is going to be equal distance from that point on the parabola down to the line directrix below it there. So let's continue with our definitions of a parabola here on our next page. If you remember about parabolas here, they have the reflective property, and all that tells you is that the rays parallel to the axis will reflect off that parabola and through that focus point F. So notice that both sides there have a mirror shape to it, and they're going to be symmetrical. So now let's actually apply this in our next question here. So in this example here, we're given that the focus point is 0, 2, and our directrix is the x-axis. And they also give us the formula here for a parabola here. So we have that A is any point x, y on the parabola P, and F prime is a point on the directrix with the same coordinate as point A. So what is the length of A F prime? Well, notice that F prime there has coordinates x, 0, and all that tells us is that our point A there is x, y, which means that their length here is just going to be the distance from 0 to y. So in other words, our length A F prime here is going to equal y. And now let's use the distance formula to create an expression that represents the length AF. Remember that our distance formula here, D, is going to equal the square root of x2 minus x1 squared plus y2 minus y1 squared. So if we plug this into our distance formula here, the distance of AF is going to equal the square root of x minus 0 squared plus y minus 2 squared. Just by plugging in my points A and F there for my x2 minus x1 and my y2 minus y1. So now let's take a look at the last question here. So now we want to write an equation that relates the two lengths and solve it for y here. This should say y. So remember that our equation of a parabola here is going to equal the set of x, y such that their distance here are going to be equal. So one of our distance, our AF prime, was equal to y, and that's going to equal our distance from A to F, which was the square root of x minus 0 squared plus y minus 2 squared. So rewriting this here, I have y is going to equal the square root of x squared plus y minus 2 squared. So let's solve this for y here by squaring both sides. That way it'll eliminate the radical, so I'm left with y squared is equal to x squared plus y minus 2 squared. So if I simplify this further, I get y squared here is equal to x squared plus, and you can use tabular for this, it'll give you y squared minus 4y plus 4 here. So it's just solving for y. I'll subtract the y squared here and subtract the y squared here, which means my y squared will cancel, and I'm left with 0 is equal to x squared minus 4y plus 4. And again, I want to isolate y here since I am solving for y, so add the 4y over, and I get 4y is equal to x squared plus 4. So just divide out your 4 here, divide out by 4, and I get that y is equal to 1 over 4 x squared plus 1. So this will be my equation for the parabola here. Just writing this more formally here, it'll be P is equal to the set x, y, such that you get the equation y is equal to 1 divided by 4x squared plus 1. And that'll be your final answer for this one here. That's it for this lesson. It was a short lesson. Thanks for watching, and if you have any questions, please bring them to class.